Welcome back, everybody, to our Huntsman Knows How podcast. This is James Ridgway with Huntsman Communications, and today we're talking about Huntsman's role in the semiconductors arena. And I've got three guests joining us today: Dr. Jay Henderson, Global Marketing Manager of Advanced Technologies; Suk-Chul Kung, Marketing Manager of Advanced Technologies for Asia Pacific Marketing; and Mark Thirsk, Managing Partner at Lynx Consulting. Welcome, gentlemen.
Good morning.
Good morning, everybody.
Jay, can you start us off by just telling us what is a semiconductor chip and why do they play such a significant role in our lives?
Sure, I'd be happy to. I mean, definitely you hear semiconductors, you hear chips, and sometimes they're used together interchangeably, and so it can be a bit confusing. Basically, semiconductor devices are these tiny chips that are made from silicon wafers that have undergone extensive processes of patterning to form these integrated circuits, right? And that allows them to perform a really wide range of functions in modern day electronic devices. I think everyone's familiar with in your computer or in your cell phone, you have your processor chip. You've also got your flash memory and your permanent memory, your solid state hard drive, things like that. But what I think a lot of people don't realize is just how ubiquitous these devices are and how many things can be made using these semiconductor processes. Fingerprint sensors, they can be formed into accelerometers, so you can have them that's what tells you if your phone is turning or moving, right? Or if you're taking steps. You've got them in your infotainment device in your car. You've got them, when you're streaming stuff off of media online, that's coming from a cloud server somewhere, and that's using all sorts of different types of semiconductor content. It's what rolls the windows up in your car. It's what sets off your airbags. I mean, it's in your smart lights. It's in your...
It's all over the place.
All over the place. You've got them in industrial applications too, smart factories. You've got workers wearing hard hats that measure their perspiration, make sure they're hydrated, AR, VR. I mean, they're literally becoming such an embedded part of our lives that they're everywhere. And what we've seen as they've proliferated everywhere, historically it's always been about going to the most advanced technology. But now a lot of these applications are bringing back uses for kind of older devices. You're just seeing this incredible broadening of the applications of where semiconductors go. It's really a kind of fascinating to watch. It's like, what's the trends in semiconductors? It's more like, what aren't the trends, right?
Yeah,
it's
so like
everywhere.
if Thanos came in and snapped his fingers and made all semiconductors just snap out of existence, we'd
be in a lot of trouble. We'd be living very boring lives.
What, sending us back to the dark ages of, that's the whole digital age is gone without them.
Right. Pre my childhood, right? I'm one of those Zennials that was born with the, digital adulthood, but the non-digital childhood. So it'd be before me.
I remember card catalog. It's okay. So, Suk-Chul, can you describe just maybe at a broad level how semiconductors are made?
It's similar as the building, right? For example, we have a land, and we have the structure, the some concrete, and some wire, and other some roof, and so on. And the kind of thing inside the semiconductor, but it's only the different scale, nanoscale. That's why it's difficult to make physically. You need the chemical, the atomic scale, the fabrication, very clean fab environment. Very similar as a building and even Lego toy, something like this.
Okay, so it's going the other direction then. Instead of going really big, we go really small. And when we go really small, I'm hearing we have to rely on chemistry to operate in that arena.
Yeah, absolutely. I mean, that's a good way of putting it, Suk-Chul, to talk about Legos, because it's kind of, you're starting with a blank wafer. It's almost like that green Lego board, right? And then you deposit a layer of materials, but then you take parts out, and then you just keep repeating it over and over and over again as you kind of build up an overall structure. If Mark wants to take a stab at explaining it better, he's probably the smartest person here.
There you go. No pressure, Mark.
Perhaps we all have memories of putting together a breadboard in school, or seeing people build circuits out of little devices and coiled wires and soldering them together. That's really what a semiconductor chip does. It takes design components, switches, storage, and integrates them onto the silicon. So at the silicon level, we build switches, build diodes, we build memory elements, and then we work to interconnect all those through the Lego type system, a layer cake type system. We stack wires and contacts on top of each other to interconnect these devices we've built in the silicon. And then we package that all up with some inert materials to make sure it's safe and doesn't corrode and doesn't degrade.
Does anybody know why they call it I've heard a conductor, but why do they call it a semiconductor?
Metal is a conductor, right? You put a battery across a piece of metal and a current flows. An insulator like a plastic or a glass, that doesn't happen. A semiconductor, if you are clever and you contaminate that semiconductor with just the right amount of material, a phosphorus or boron, it turns into a wire. And you can control the flow of current in that semiconductor by applying an external field. So it's just what it says. It's sort of a conductor, but it's sometimes on, sometimes off, depending on the conditions that the semiconductor sees.
Yeah, it's really unimaginable the amount of control they have over these materials, both in the size, the exact level of conductivity, and everything. The way they interplay together between different layers, it's really pretty remarkable, and that's why this industry is so incredibly sensitive to defects. Any kind of defect or impurity or anything that happens in there can really change the way the device is supposed to make to work, right? And that's why purity is so critical and so important in this industry. What can cause a defect in these types of devices is even the smallest or tiniest particle can create a defect. Either it can bridge across two different circuits, or it can prevent the next layer from depositing correctly. What we're really focused heavily on is the trace metal contamination. For example, something like a sodium ion. We're trying to get down into parts per, like single parts per billion, parts per trillion. Our customers are talking about parts per quadrillion of these trace metals. And the reason is, especially as we move into a lot of automotive applications, historically the industry has always looked at, does it work like kind of when it's made, right? And that's why there's always been a focus on things like particles, because that's the kind of thing that causes a defect when the chip is made. Your phone works for maybe 2 or 3 years and then you get a new one. But, I've got a 14-year-old car, right? I want to drive it another 5 years. Mm-hmm. So if you're talking now that these chips are going into critical safety or self-driving or automated driving, like the chip has to work for 10 or 15, maybe even 20 years, and it has to perform or people's lives can be at risk, right?
And this is where purity comes in?
This is where purity comes in, because those little bits of sodium ions that, okay, maybe it wasn't a problem when the device was manufactured, but as you keep applying those fields and those currents, that sodium ion can migrate, and eventually it can cause a defect later down the line, and parts of devices start failing over time. And so now we're looking at, the features are getting smaller, so it's easier for them to migrate. The features are getting smaller, so it's easier for the particles to create those defect areas, and the particles that are allowed to be in there are getting even smaller and smaller. And you're looking at, the device has to work when it's made and has to work for 10 or 15 years, and it's critical to safety. So the industry wants the highest purity, and they also want it the exact same every single time. And so that's where, Huntsman is really trying to invest right now, is in that type of quality.
Sakshul, I'm starting to understand some of the challenges here, and as Jay said, that there's a role Huntsman's playing here. So could you talk to us a little bit about the innovations taking place to overcome some of those challenges?
Yeah, so Jay is correct. We need to understand the semiconductor development history, first of all. Since the first IC chip was launched in 1963, semiconductor pattern size is getting smaller and smaller continually. So we call the Moore's law. That number of transistor is double about every 2 years. In addition, 3D technology also is becoming mainstream. and overcome technology limitation of 2D scale down. That means there's more layer and cleaning step also being increased. Huntsman is a well-aligned semiconductor technical roadmap. We have an E-grade program improving purity and quality. It contributes a lot and enables next generation semiconductor device node. And Huntsman has various E-grade portfolio and developing many new E-grade amines, which give many options for cleaner formulation, for better performance and advanced semiconductor technology.
And so does that mean we're having to go into, I'm just trying to imagine how you accomplish something like that, and like how do you get into a place that has no unwanted random particles that, you know what I mean? It escapes me how you even accomplish something like that.
You know, Huntsman historically, especially our division of performance products, we're a huge manufacturer of amine chemistries, you know, things with nitrogens in them. We make large volumes of these amines, lots and lots of amines, hundreds or whatever of different types of amines.
What's an amine?
It's an organic compound with a nitrogen in it, basically. So that's our focus, right? But those amines don't all meet the semiconductor industry's needs for purity and for trace metals. We have been in the semiconductor industry for over 20 years. We've got a lot of experience in this industry, but it's been on some products that we've kind of optimized those products for the industry. What we're really trying to do right now is make it so that the industry can come to us and say, we want any of the amines you make. Just pick an amine off our shelf. We've got the technology, the know-how, and the capability to take that amine and purify it to your standards, to what you need. And you'll get it the quality you need every time. And that's really where we're investing. We're investing in our Conroe, Texas facility. We're also evaluating investments in Europe, Asia, and then another one in our Gulf Coast facility. So we're expanding this technology and this capability everywhere, really looking to bring a much broader range of products to the market. Really, you know, especially focused on chemistries that we're trying to make safer. So alternatives to a widely used amine, tetramethyl ammonium hydroxide, or TMAH. We have similar quaternary amines, but with safer profiles. Also solvents that can replace NMP. And so we're trying to find safer chemistries that also work better in some of these extremely advanced nodes, also higher purity and consistency.
So Mark, it sounds like a lot of this happens in the preparation. It happens in the tools that we can offer, what would you say, manufacturers?
Yeah, I think the electronics industry is one that is foreign to many people. If you go to a major electronics or semiconductor manufacturing facility, where the manufacturing is done is almost a completely unknown environment to most people. The air is filtered continuously. The ceiling of the room is one enormous filter, and the air is pushed down through the ceiling, goes vertically down, and is sucked out through the floor and returned again. The people who work in the room wear special clothing that protects or stops dust from their skin or dust from their clothes exiting. In some places, they breathe out through a filter. They breathe out into a sort of space helmet, and the air that they breathe out is filtered before it's exhausted. The product, the wafers that we work on, are kept in special boxes, which are ultra clean. And even though the environment is very, very pure, very clean, the wafers are protected from that environment. They're moved around in these closed boxes, open to go into the machines that process them. And the chemicals that go in, Jay was talking about some of the inventions and the novel chemicals that we're using, but they have to be purified to incredible purity. Somebody showed an example of this. If you imagine a lake or a reservoir that is probably a mile or 2 kilometers across, something that might feed the water supply for a major city, and you put one drop of contaminated water supply, that's already too high a contamination level for semiconductors.
Wow.
It's almost unimaginable that we can remove contaminants to that level.
To recap and circle back on all this, I mean, Huntsman's role is in enabling, that's what I think I'm hearing, enabling our customers to be able to achieve those results.
Yes, correct. As I mentioned, the chip scale is getting smaller and smaller. That means the threshold is getting lower and lower. If our materials has a contaminate and then not good purity, our customer cannot make their device. They put a lot of effort and then additional money to purify. And then Huntsman has a core technology about the amine and the purification. That's why our position and our role is very important this market.
It's interesting. A lot of the ways that this market is viewed is I think everyone's heard of and familiar with the sort of, when it comes to safety, zero incident culture. A lot of the thoughts and the methodologies and the thinking about zero incidents with safety, I see a lot of that same mindset being pulled into quality in the semiconductor side. To the goal is to achieve zero defects, right? And how do you get there? What's the roadmap, right? And so as a component supplier and a sub supplier, we provide a means that go into these formulated cleans. The formulated cleans are going into applications where just a typical bulk clean doesn't work anymore. It's not the right technology. They have to go to a more advanced clean, and that needs more advanced materials, and those materials have to be really high purity. So if you're going to achieve zero defects, you've got to have quality and purity all the way through that chain. We have to make the material right. We have to supply it right. Our customer has to blend it right. Our customer has to supply it right, and the chip user has to use it right. So quality has to go all the way throughout. And just like safety, if you're going to achieve zero defects, it's got to go all the way through there, and you have to have the right mindset.
So, over the last year or two, you saw all kinds of headlines about semiconductor shortages, overstock. So what's happening on the larger macro scale there?
What happened through COVID was that we needed more chips, actually. The car makers needed a few less, and part of the problem was that they unwound some of their orders. They slowed down their production. But the computer makers, phone makers, tablet makers responded to everybody working from home and needing new devices at home. So during COVID, the COVID pandemic, we actually made a lot more chips, and balances that came from that caused a lot of the shortages. So the automotive makers stopped buying, and then they tried to start buying again and found that the suppliers who were making their chips were busy doing other things. And they came and said, well, we're your loyal customers. We'd like you to make our products again. And the suppliers said, well, we will, but we're very busy. So there has been a global reordering of the supply chain, and we're getting back to normal again, and it will probably be back to normal this year. So as everybody on the planet is using more semiconductors, we're having to build more chips. The economic slowdown will impact that somewhat. We're seeing inflation and investment slow down in 2023, and so the semiconductor market, and indeed every market, is having to struggle with a little bit of reduced demand this year. But we believe the semiconductor market will continue to penetrate the global economy, and everyone will want to have more electronics, more automation, more help from electronics in their lives. And when there's a recession or when there's problems in one part of the world, materials or chips or systems can be delayed, and we all feel that.
Yeah, and that's certainly what we're seeing with the CHIPS Act and some of the, not just the U.S. CHIPS Act, but there's multiple CHIPS Acts globally, and we're just seeing this regionalization, and a lot of that comes online in maybe late 24 and early 25. The last half of this decade should be very exciting, and we're just trying to be ready for it here.
What sounds like historically the engineering challenge has been, how do I make this smaller, and it gets twice as small on
every 2 years, right? Moore's law. Yeah.
Yeah, and I'm just trying to wrap my head around the logic of that, because it sounds like at some point you're getting to a place that my imagination can't go. But in pursuing that goal, what does that look like 10, 20 years from now? I mean, do we even have a sense for where this is going?
Yeah, yeah. As you mentioned, the semiconductor market is keep growing, no doubt, and the many innovation technology are coming. Obviously, there would be the challenge in terms of performance, quality, and purity. And actually, it's not easy to enable this kind of new technology by oneself. So I expected that the collaboration and partnership is the key among the chip design house, chip manufacturer, material supplier, and tool maker in the future. So we also need to put effort to build the partnership with the key customer. But also EHS and ESG management are also very important. So chip makers would try to develop eco-friendly solution, which also could be marketing point for the position in the market. Anyways, yeah, it's getting complicated and they need to require the high technologies. That's why we need to collaborate to overcome the issue in the future.
Yeah, I think that's a good point. In order for us to continue to enable some of these leading edge technologies, the chips have to continue improving. They have to continue to get smaller. We need more transistors in a given area. We need more memory on a solid state drive. We need the cost of those devices to come down. There's technologies we're not even imagining. There's wearable technologies. There's all sorts of stuff. As these things become ubiquitous and cheap and more advanced, there's still seeing things I think that we haven't necessarily understood. Another direction we're seeing the industry take is they're really starting to focus on sustainability. Semi just took a big step in forming their sustainability council. We're a member of Semi and of the electronic materials group there. But they're really starting to focus on the power usage, the water usage, the greenhouse gas chemicals that are often in there. And so there's a big focus on making sustainability a part of the semiconductor industry that I think was not necessarily there in the past. I mean, just as we move to these smaller nodes and start going to things like extreme UV, the amount of power that's required to operate those tools is immense. And so I think the industry is maybe a little late, but is moving aggressively to start focusing on sustainability. Doesn't necessarily impact us as much because we're pretty far down the chain, but it's still something that we're looking at too.
Well, before we wrap up, Mark, do you want to close us out with any final thoughts?
I've told the story several times that when I started in this industry, we were working at about 5 microns, and someone put an academic paper on my desk which said that the limit of our technology was going to be 1 micron. We are now something like 1,000 times smaller than that. And every few years, we have heard, yes, this is a showstopper. We can't get beyond this. We don't know how to solve this problem. We need a miracle to get beyond this. And somehow someone has come up with that miracle. And we've developed new technologies, new chemistries, I won't say new physics, but we've used physics in exciting new ways to solve the problems and keep manufacturing. And there doesn't seem to be any slowdown in that process. So yeah, it's been a wild ride.
Well, thank you, gents, for your time and your insights today. And we invite anyone listening, if you have any questions or want to know more about the material solutions discussed today, you can send those to huntsmanknowshow@huntsman.com. Thank you all for tuning in, and we'll see you next time.